Imagine this. Your heart suddenly stops. In an instant, the organ that has been pumping blood through your body for decades falls silent. No warning, no heartbeat, no circulation. But what happens next? Does the body simply switch off? Not exactly. For the next 60 seconds, something remarkable happens inside you. Your brain, heart, and billions of cells begin a race against time. And what happens during that first minute can determine whether the process can still be reversed, or whether the damage becomes permanent. So, let's follow the human body, second by second, through the first minute after cardiac arrest. Because there is an important distinction. When we talk about someone dying, we often imagine a single instant. Biologically, it is more complicated. Cardiac arrest, when the heart stops pumping effectively, can sometimes be reversed. Irreversible death occurs when the body's vital systems have suffered damage that can no longer be recovered. So, for this countdown, we're starting at the moment the heart stops pumping blood effectively. 0 seconds. The heart stops producing effective circulation. Blood is no longer being pushed around the body. That means oxygen-rich blood is no longer reaching the brain, the muscles, or the organs. And the most vulnerable organ is the brain. Your brain consumes an enormous amount of energy, even though it makes up only a small fraction of your body's mass. It doesn't store much oxygen. It doesn't have a backup battery. So when blood flow stops, the countdown begins. The first few seconds. Your brain doesn't immediately shut down. For a brief period, neurons can continue functioning using the energy and oxygen that remain available inside the tissues. But without fresh blood flow, that supply is rapidly disappearing. The brain begins losing its ability to maintain normal electrical activity. At the same time, blood pressure collapses because the heart is no longer generating circulation. Your organs are now effectively cut off from their continuous supply of oxygen and nutrients. And yet, from the outside, the body may appear surprisingly still. The heart isn't pumping, the person isn't responding normally. But inside, millions of cells are still desperately trying to maintain themselves. Around 10 seconds. For many people in cardiac arrest, consciousness is lost within seconds because the brain can no longer sustain normal function without adequate blood flow. The lights don't necessarily go out everywhere at exactly the same moment. Different brain regions fail at different rates, but the organized activity required for consciousness can disappear remarkably quickly. This is one reason cardiac arrest is so dangerous. A person can become unconscious before many of the body's cells have actually died. And that distinction matters. Because the process is not instant. It is a cascade. Around 20 seconds. The brain is now operating under severe oxygen deprivation. Neurons normally depend on a constant supply of oxygen and glucose to produce ATP, the molecule cells use to power almost everything they do. Without enough ATP, cellular machinery begins to fail. Ion pumps that normally maintain the electrical balance across neuron membranes start struggling. Electrical gradients collapse. Neurons can no longer communicate normally. And the brain's carefully coordinated network begins breaking down. But the most important point is this. The cells are not simply sitting there waiting to die. They are actively fighting to keep their internal environment stable. For a while, they can compensate. But every second without circulation makes that harder. Around 30 seconds. The problem is no longer limited to the brain. Every organ that depends on circulation is being affected. The kidneys, the liver, the heart itself, the muscles, the cells lining blood vessels. All of them are experiencing oxygen deprivation. Without oxygen, cells increasingly rely on less efficient forms of energy production. This can cause acidic byproducts to accumulate. The chemistry inside cells begins to change. And the longer circulation remains absent, the more difficult it becomes for cells to maintain their normal structure and function. At this point, the body is not simply turned off. It is undergoing a rapidly escalating biological crisis. Around 40 seconds. Inside the brain, the situation becomes increasingly unstable. Neurons are particularly vulnerable because they require enormous amounts of energy to maintain their electrical state. As energy stores fall, cellular membranes lose their ability to control the movement of ions. This can trigger abnormal electrical activity. Chemical signals can also become disrupted. And as the energy crisis continues, the delicate balance that keeps neurons alive begins to collapse. But here's something important. The absence of consciousness does not automatically mean that every brain cell is dead. This is why emergency medicine focuses so heavily on restoring circulation as quickly as possible. CPR and defibrillation, when appropriate, can sometimes restore effective circulation after cardiac arrest. The goal is to restart the flow of oxygenated blood before irreversible injury develops, because the clock is still running. Around 50 seconds, the brain is now approaching a critical point. Some cells may still be viable. Others are beginning to suffer severe injury. And the longer the lack of blood flow continues, the greater the risk of permanent neurological damage. This is why every minute matters during cardiac arrest. It is also why immediate CPR can be so important. CPR doesn't necessarily mean the heart has restarted. Instead, chest compressions can help move some blood through the body, providing at least partial circulation until more definitive treatment can be given. In other words, you're buying time. You're keeping the biological clock from moving forward as quickly as it otherwise would. 60 seconds. 1 minute has passed. But this is not a magical point where the body suddenly becomes irreversibly dead. There is no universal 60-second switch. The actual timeline varies depending on the circumstances. Temperature, cause of cardiac arrest, remaining oxygen, overall health, how quickly CPR begins, whether circulation is restored. All of these factors can change the outcome. What we can say is that prolonged interruption of blood flow causes progressively severe injury, and the brain is among the organs most vulnerable to that damage. But there's another fascinating question. If the heart has stopped and the person is unconscious, is the brain completely silent? Not necessarily. This is where science gets much more complicated. Researchers have recorded electrical activity in brains during periods surrounding cardiac arrest, including in some monitored patients. But interpreting that activity is extremely difficult. Electrical signals do not automatically mean consciousness, and they certainly don't prove that a person is experiencing thoughts, memories, or an awareness of what is happening. So when you hear stories about people describing experiences during cardiac arrest, science cannot simply dismiss every report. But neither can it conclude that those experiences reveal what happens after death. There is still a great deal we don't understand, and that may be the most fascinating part. Because death isn't a single switch, it is a process. The heart can stop, blood flow can cease, consciousness can disappear, cells can begin failing. And yet, for a period of time, some biological processes continue. The boundary between life and irreversible death is therefore much more complex than the simple idea of a body turning off. Modern medicine exists in that gap. Every second of CPR, every defibrillation attempt, every effort to restore circulation. They are attempts to interrupt the cascade before cellular damage becomes irreversible. And that is why the first minute matters so much. Not because exactly 60 seconds marks the end, but because every second without circulation pushes the body further toward a point from which it may not be able to return. So the next time you think of death as an instant, remember what is actually happening. The heart may stop in a moment, but the biology of dying unfolds over time. A race measured not just in minutes, but in seconds. Follow Beyond BioScience, where science becomes impossible to ignore.